Welcome to Tomorrow Unveiled.
We're here at the end of the final week of November 2025, and if you're listening to this, you are really patching the first wave of a genuine discontinuity in the history of artificial intelligence.
A discontinuity, that's a strong word.
It is. The feeling in the research labs, in the boardrooms this week, it wasn't about incremental improvement. It felt like a fundamental philosophical change.
Absolutely. And our mission here on Tomorrow Unveiled is to take this enormous stack of proprietary research and corroborated reports.
Huge stack.
A huge stack, compiled by our dedicated research team who, I have to say, pulled some serious all-nighters this week. And our job is to extract that crucial signal from all the data noise.
And the signal is loud and clear.
What is it?
The evidence shows that the rules of the AI game that we've all learned over the past couple of years, they've officially changed.
Okay, so let's define that change. For the last few years, we've been in what you might call the era of stochastic generation.
That's a good way to put it. Think of it as the era of the incredibly eloquent guesser. AI models were these sophisticated probability machines. They were fantastic at generating fluent human-like text by just predicting the next word. But they were fundamentally prone to massive confidence-filled errors.
The hallucinations.
The hallucinations, exactly.
The charming liar. It sounded so good you wanted to believe it, even if the math was completely impossible.
Precisely. And what the sources all confirm this week is a decisive pivot. We are moving into the era of verifiable agency.
Okay, verifiable agency. Break that down for us.
It's a shift where models move from merely generating text, chatting, to actually acting in the real world. Acting, verifying their own logical steps, and crucially, remembering complex context over the long term. They're becoming intelligent, autonomous collaborators who are now required to show their work.
And that shift changes everything. It impacts what geopolitical strategy, it dictates how big companies structure their IT spend.
It even forces us to rethink how we physically cool the infrastructure running these things.
Because if AI can now reliably verify its own logic, the barriers to delegating really high-stakes tasks just plummet, don't they?
They drop dramatically.
Yeah.
We're talking about writing mission-critical code or diagnosing medical conditions. This moment, it truly is a discontinuity.
So to give you a roadmap for this deep dive on Tomorrow Unveiled, we've distilled this transformation into 6 critical pillars. And these are cross-corroborated, confirmed by all the data our research team collected.
First, we're going to explore the verifiable intelligence breakthrough in math and code. This is the move into what's called System 2 reasoning.
Then we'll hit the great price compression in these top-tier models, which is making high-level reasoning affordable for the first time.
After that, the architectural battle between centralized cloud agency and the new wave of decentralized local edge AI.
And you mentioned the physical constraints. We'll get into the massive and, frankly, accelerating infrastructure bottleneck. That's power, cooling, and global supply chain geopolitics.
Then we'll look at the immediate impact. AI's deployment in life sciences and healthcare. It's moving from the lab to the clinic right now.
And finally, the big one. The profound and imminent economic implications for the global workforce, which is crystallized by a single, pretty stark finding that will undoubtedly shape policy debates for years to come.
It's an enormous amount of change packed into just 1 week.
It really is. And we are going to unpack every single layer of it for you right now, starting with, I think, the biggest breakthrough. Models that are moving beyond vibes and insisting on verification.
Okay, let's get into it.
So for years, the major frontier models, they've operated on this idea of probabilistic fluency. They knew what a correct answer was supposed to look like just based on language pattern.
Try a good vibe of it.
The vibe of it, exactly. But they really struggled with abstract step-by-step logic. The single most important signal from the last 7 days is that competitors are now demanding verification in the most rigorous domains you can imagine.
This is the definitive transition to what psychologists call System 2 thinking. It's deliberate, it's verifiable, it's logically procedural thought. We're moving far past the intuitive, probabilistic System 1 stuff that dominated all the previous models.
And the evidence for this shift is most stark in, what, math and software engineering?
Exactly. The 2 places where you absolutely have to show your work.
Let's start with the math, because the scale of this achievement is genuinely hard to process.
Okay, so DeepSeek released an open-weights 685 billion parameter model. It's called Math V2.
Open weights, meaning anyone can access and build on it.
That's right.
Yeah.
And to clarify a term we're going to use a lot, it uses a mixture of experts architecture, or MOE.
Right, the MOE model.
So instead of one gigantic brain trying to do everything, the model distributes the task across specialized subnetworks, these little experts, and it only engages the ones it needs for a specific problem.
Which makes it incredibly efficient and powerful for a targeted task like, well, math.
Precisely. And the power of this specific MOE was demonstrated by the benchmarks it just completely crushed.
So it achieved gold medal mathematical reasoning capabilities, but the specifics are what really define this discontinuity, aren't they?
They are. Our research team noted that it scored a jaw-dropping 118 out of 120 on the William Lowell Putnam Mathematical Competition.
Okay, we need to pause on that. The Putnam exam is not just some standard university test. This thing is notoriously difficult.
Oh, it's brutal.
It's designed to challenge the absolute brightest undergraduate math students in the US and Canada. A human scoring above 50 is considered an outstanding achievement. A score of 90 puts you in the highest possible echelon of mathematical talent.
And this AI scored 118 out of 120.
That's staggering.
And not only that, the model also achieved gold medal scores on the International Mathematical Olympiad, the IMO. This isn't just a marginal improvement over the last model. This is proof that autonomous, large-scale reasoning can now tackle abstract, unsolved problems, not just regurgitate things it's seen before.
But the crucial insight, as you mentioned before we started, isn't just the score itself, it's how it got that score. How did it overcome that tendency of previous models to use, well, to cheat, basically, to use logical shortcuts?
Right. The why is the process-supervised training approach.
No.
This is the key. Previous models suffered from something called reward hacking.
Reward hacking.
It means they were rewarded if the final answer was correct, regardless of the logical steps they took to get there. They often made compensating errors along the way, which resulted in really brittle, untrustworthy reasoning.
So it's like getting the right destination on a map, but only after taking 3 wrong turns that somehow miraculously cancel each other out. You would never trust that map again.
You wouldn't. Not for mission-critical tasks. And DeepSeek Math v2 changes the game entirely by using a dual architecture. It has a theorem generator and a verifier.
Okay, so one part proposes and the other part critiques.
Exactly. The generator proposes the steps of the mathematical proof, and the verifier critiques the logic of each individual step in real time. It only proceeds when the logic is absolutely sound.
So this is the AI equivalent of an obsessive, detail-oriented editor working hand-in-hand with brilliant writer. It's optimizing for proof quality and rigorous logical deduction. It's forcing itself to genuinely show its work.
Yes. And this internal loop of self-correction, you could almost call it metacognition.
Yeah.
It means the model is genuinely optimizing for logical integrity. This capability elevates the AI from being a complex calculator to a legitimate research partner, capable of generating verifiable, rigorous, step-by-step proofs.
And because it's an open weights model, the cost to replicate this kind of high-level reasoning just drops dramatically.
It lowers the barrier to entry for institutions all over the world.
That intersection of sheer capability and broad accessibility is it's mind-boggling. And we saw a parallel leap, a very similar kind of leap, in the domain of software engineering, which needs that same kind of meticulous step-by-step verification.
Absolutely. Anthropic's Claude Opus 4.5 is confirmed across multiple independent reports as exhibiting a generational leap in what we call agentic capabilities.
So agents, they don't just chat. They use the computer environment, right? They use browsers, terminals, code editors.
Exactly. They manage complex, multi-step workflows all on their own. So if DeepSeek proved logic, Opus 4.5 proved action.
And the measurement here, the big benchmark, is the SWE-bench Verified benchmark. What is a specific number, that 80.9%? What does it tell us about how useful this agent actually is?
Well, SWE-bench is a highly rigorous test. It's derived from real-world GitHub issues. This is not some theoretical pop quiz. It forces the model to load an entire code base, reproduce a bug that a human recorded, and then write both a fix and a test case that verifies the fix actually works.
So at 80.9%, Opus 4.5 has crossed a critical threshold of practical utility.
A huge one.
Wait, hold on. If it's fixing 80.9% of real-world mid-level bugs all by itself, where does the remaining 19.1% fail? Is this just, optimistic marketing, or does the data really stand up to peer scrutiny?
That is a vital, skeptical question to ask. And the research shows the remaining failures usually fall into about 3 categories.
Okay.
There are issues requiring significant human domain expertise that just isn't written down to the source material. There are tasks that need inter-repo coordination across multiple disconnected code bases.
Really complex stuff.
Really complex. Or bugs that are rooted in very rare specific compiler or operating system configurations.
Yeah.
However, resolving 8 out of 10 tickets means the model moves from being a coding assistant
To a true autonomous coding agent.
That's the leap.
So the implication is that the score makes it a viable replacement, or, maybe more accurately, a force multiplier for human junior developers in a huge array of common engineering tasks.
Yes. But again, like with the math, the true breakthrough is in how it works. Our research team highlighted its display of metacognitive behaviors, which we're calling active inference.
Active inference.
So when it's given a complex task, it doesn't just blindly start executing. It generates a detailed plan.md file first. It outlines its strategy, the trade-offs it considered, and the tools it's planning to use.
It's not just executing code, it's reasoning about the execution itself.
Precisely. And if it hits a wall, let's say it gets a compiler error, it doesn't just stop and wait for a human. It analyzes the error message, it self-corrects its strategy, and it attempts an alternative approach.
So it's demonstrating genuine resilience. It's interacting with its environment, observing the results, and then dynamically adjusting its plan on the fly.
Which transforms it from a static model into a truly dynamic, reliable digital worker ready for deployment right now.
And that takes us immediately to the economic consequences of this capability, because if the smartest AI in the world can suddenly verify its work and act resiliently, but it's too expensive to run, it remains a theory.
Exactly. The transition you just described, from high-fluency guessing to verifiable action, is inherently compute-intensive. It just is.
It has to be.
An agent that runs dozens of internal thought loops and self-correction steps consumes far more tokens than a simple Q&A bot. So for this verified agency to scale and become the default business tool, two things had to happen. The price of intelligence had to drop dramatically, and the underlying architectural limitations like memory had to be solved.
And this week, we saw Anthropic deliver a monumental economic shock to the entire system.
A huge shock.
The dedicated research team's analysis shows this was not some minor price adjustment. This was a deliberate, incredibly aggressive maneuver.
It was. Anthropic slashed the cost for their flagship model, Opus 4.5, by roughly 2/3, a full 66% cheaper than the previous Opus 3 generation.
And the key data point is that the input cost dropped from $15 per million tokens to just $5 per million tokens.
This is a profound deflationary shock applied directly to the cost of accessing high-level AI reasoning and verification.
$5 per million tokens. That effectively commoditizes high-level reasoning, doesn't it? What specific tasks were just prohibitively expensive at $15 that are suddenly viable at $5?
Think about core enterprise functions. At $15 per million tokens, running a continuous audit of thousands of financial contracts, or performing rigorous legal discovery, or executing multi-step market analysis for every single client interaction was it was too expensive.
The token cost would be astronomical?
Astronomical. An agent consumes tokens for planning, for execution, for verification. At the previous rate, those workflows cost hundreds of dollars each.
And now?
Now, at $5, they're economically viable at scale. Anthropic is basically signaling that they want Opus 4.5 to be the default choice, the affordable, smart workhorse driving every autonomous workflow in the enterprise layer.
So by making their brains so economically rational, they're trying to capture that entire agentic application layer before their competition can even react and match the price point.
That's the move. And this cost drop is coupled with their prompt caching feature, which allows enterprises to load massive stateful contexts like entire security manuals or API documentation at a 90% discount for repeated queries.
Which brings us directly to that other major architectural problem that needed solving, the memory crisis.
Exactly. We need to define a term here for a second. OR-AG, or Retrieval Augmented Generation.
Right.
OR-AG is the traditional method. It's where an LLM reaches out to a database to grab relevant chunks of text to answer a query. It's often slow, it can be cumbersome, and the quality of the answer really depends heavily on the quality of the little chunk it managed to retrieve.
So if these agents are going to manage complex projects for months on end, they can't rely on brittle ag, and they certainly can't have, amnesia.
Exactly. The core problem is that traditional LLMs are stateless. They forget the conversation the moment the input stops.
Right.
Our research team identified 3 converging architectural solutions released just this week to tackle this amnesia problem. It really demonstrates that the future of AI is modular, not monolithic.
Okay, let's start with the one that feels the most comprehensive. The General Agentic Memory, or GAM framework.
This comes from the Beijing Academy of Artificial Intelligence, or BAAI. And GAM is a fundamental paradigm shift away from that static array system. It operates on a dynamic memory compiler concept. It functions like a sophisticated, just-in-time research assistant.
Okay, so how does that work in practice?
It involves two main components. First, there's the offline memorizer. This thing continuously compresses the agent's historical interactions, its thoughts, its outputs, into a highly structured page store.
Okay.
Then, when the agent receives a new complex query, the online researcher module performs a deep synthesis loop over that page store. It doesn't just pull up raw text. It synthesizes a bespoke, coherent context tailored specifically for the current task.
So instead of finding a static chunk of text, the agent is effectively writing a miniature, customized report for itself based on months of data, making that information instantly relevant.
Exactly. This allows agents to maintain consistent personas and manage project states over weeks or even months. It enables true, lifelong learning capabilities.
So that's one solution. The second one is fascinating because it seems to mirror human biology, the visual compression and forgetting mechanisms from DeepSeek's research.
Right. This involves converting high-resolution tokens into images and then progressively downsampling the resolution of older memories.
So it's making old memories fuzzier.
It is. Instead of storing all context as massive, high-cost, high-resolution text tokens, the system converts older context into lower-resolution visual representations using optical character recognition. Important recent memories stay crystal clear, while older, less critical memories become, as you say, fuzzier. But they're still semantically accessible and, crucially, very cheap to store.
And that reduction in token usage, 7 to 10 times less? That's the key economic driver here.
It is. It means theoretically unlimited context windows become manageable because the computational cost of accessing old memories is minimized.
And the third piece of the puzzle.
Finally, Google Research unveiled the nested learning paradigm. This views models not as single entities, but as nested optimization problems with a cascading memory system.
Cascading memory.
This allows memory banks to update at varying frequencies. Some update daily, some hourly, some weekly. This allows for genuine continual learning without needing these distinct, costly, full retraining phases for the whole model.
So the convergence of these three solutions, GAM for the synthesis, visual compression for cost management, and nested learning for continuous adaptation, it suggests that the memory crisis, which was a fundamental barrier to delegation, is rapidly being dismantled.
It is.
But while Opus 4.5 is dominating the cloud, this agency revolution is also happening right on your desktop, and that demands a completely different architectural approach, local intelligence.
Microsoft validated that counter-hypothesis this week with Farrah 7b. It's a small language model, an SLM, designed specifically to run locally on consumer and enterprise devices. This is the heart of the edge AI trend.
And 7 billion parameters is tiny compared to the hundreds of billions we were just talking about. Yet Farrah 7b promises this revolutionary capability using the pixel-in, action-out paradigm.
It's a brilliant pivot away from fragility. Traditional web browsing agents, they rely on brittle HTML parsing, which breaks every single time a website updates its code.
Right.
Farrah 7b bypasses this entirely. It relies on visual perception. Its input is a screenshot of the desktop, and its output is the precise XY coordinates for a mouse click or the text string for a keyboard event.
So it literally sees the UI components, the buttons, the menus, the text fields, exactly like a human does, which makes it robust to back-end code changes and applicable to any visual interface.
Any visual interface, whether it's a standard application, a proprietary enterprise tool, or even a remote desktop connection.
But the real strategic advantage here is that this local execution addresses the two primary existential threats to widespread AI agent adoption, right?
Yeah.
Which are privacy and latency.
Absolutely. Explain the privacy win here.
Well, since the model runs entirely on your device, highly sensitive data, your bank account logins, proprietary internal files, your private emails, it never needs to be streamed to an external cloud server for processing.
Which satisfies critical enterprise compliance and individual privacy concerns.
Exactly. And furthermore, latency is solved because the UI interactions operate with the immediacy of a local application. You're not waiting several seconds for a cloud round trip, which leads to a much more fluid, trustworthy interaction.
But training a model to interact with any UI seems like a Herculean task. How did they actually achieve that generalizability?
They use something called TraceGen, which is a massive synthetic data generation pipeline. They created a simulation environment with, I think, 7,000 real-world software domains and generated over 1 million verified actions.
A million actions.
And crucially, the synthetic data included human-like errors, typos, missed clicks, and then the subsequent successful corrections. It taught the model resilience and self-healing in a controlled way that real-world training data often lacks.
And since this agent is interacting with local, sensitive files, safety has to be paramount. This critical points protocol seems like an absolutely necessary guardrail for building public trust.
It's essential. The model is explicitly trained to recognize high-risk actions, delete all, transfer funds, execute payment, and it automatically pauses execution to trigger a visual UI prompt that requests explicit human confirmation.
A human-in-the-loop design.
A built-in human-in-the-loop design. It ensures that even a highly autonomous local agent doesn't inadvertently cause some huge financial or administrative disaster.
So whether they are large and in the cloud or small and on your desktop, the era of verifiable autonomous agents is absolutely here.
We love hearing your thoughts on Tomorrow Unveiled. This shift from vibe to verification is so fundamental. We just discussed two powerful yet different models, the verified cloud intelligence of Opus 4.5 and the local privacy-focused execution of Farrah 7B. Which breakthrough do you think will impact your daily work first? Leave a comment and let us know what you think.
Okay, so as we've established, the software is now breathtakingly smart, and it's becoming increasingly affordable.
Right.
But none of these breakthroughs, not the math, not the autonomous coding, not the local agents, none of it can operate without the physical infrastructure to run them. The AI arms race has now shifted decisively into the domain of power, cooling, and geopolitical control over manufacturing capacity.
And our research team found that the physical reality of AI is hardening. It's leading to a new set of critical constraints that are now dictating national policy.
Let's start with the big one, the cooling and power crisis.
Okay.
The data confirms it. The industry's single biggest bottleneck is no longer the raw availability of chips. It's the power required to run those chips and the cooling required to stop them from melting.
Literally melting.
The energy density of modern AI servers, packed with these cutting-edge GPUs, it generates heat loads that traditional air-conditioned data centers were simply never designed to handle.
And we saw specific, really alarming, real-world examples of this disruption just this past week. The reports detailed major financial exchanges being briefly disrupted by cooling failures in AI data centers that were under stress.
This isn't just an IT budget problem anymore. It's an operational stability issue for critical global infrastructure.
So this physical limitation is driving a massive sector-wide pivot toward liquid cooling and effective heat reuse.
It is. We're seeing industrial giants like Eaton acquiring thermal management businesses just to rapidly expand their liquid cooling capacity for AI servers. And companies like Microsoft are pioneering entirely new architectures, including water-free cooling.
Why water-free?
Because the demand for traditional water sources for cooling is just becoming unsustainable in many regions.
It sounds like we are entering a new phase of industrial necessity, where the local energy grid and water supply literally dictates where these systems can even be built.
Absolutely. Analysts are now warning that if AI growth continues on its current trajectory, the U.S. alone could face a potential 45 gigawatt power shortfall by 2028.
45 gigawatts. Can you put that in context for us?
A single gigawatt can power hundreds of thousands of homes. We're talking about hyperscale data centers potentially consuming somewhere between 7% and 12% of all U.S. electricity by 2030.
That's an incredible number.
The laws of physics are providing hard constraints that the speed of software innovation simply cannot ignore.
And this infrastructural strain, coupled with this intense geopolitical competition over who controls the technology, it seems to have triggered an unprecedented federal response in the United States.
It has. Our research highlights the executive order launching the Genesis mission, and it's being characterized by officials as the largest mobilization of federal scientific resources since the Apollo-era space race.
That comparison, the Apollo era, that really underscores the sense of urgency, doesn't it? What is the Genesis mission specifically designed to achieve?
The primary goal is to integrate existing national laboratories, like Argonne and Oak Ridge, in these massive federal supercomputers, including the new 100,000 GPU Solstice computer, into one unified, closed-loop AI experimentation platform.
So it's treating AI not as a consumer application, but as a critical piece of national scientific infrastructure.
Exactly. It's not just about giving researchers access to compute time. It's about systematically consolidating decades of fragmented federal scientific data sets in biology and materials and energy, and applying this new verifiable agency AI directly to them.
So it's breaking down bureaucratic silos.
It is. The mission is explicitly designed to accelerate discovery in these high-stakes, capital-intensive areas where the U.S. wants to maintain a global lead: nuclear fusion energy, next-generation semiconductors, biotechnology, and advanced material science. This is a clear policy signal that the U.S. views AI capacity as a core national security priority, on par with the Manhattan Project.
And this physical arms race demands not only immense power, but also direct control over the manufacturing of the components. And we saw significant strategic moves this week toward vertical integration and supply chain resilience.
The partnership between OpenAI and Foxconn, or Han Hai, is highly instructive here. They announced a strategic collaboration to manufacture next-generation AI data center hardware, including specialized server racks and sophisticated cooling systems directly within the United States.
Which is a clear move toward vertical integration. It ensures greater control over their customized hardware and insulates them against potential geopolitical supply chain disruptions in East Asia.
And beyond the U.S., the crucial memory sector is also shoring up its supply. Micron announced a massive $9.6 billion investment to build a new high-bandwidth memory, or HBM, chip plant in Japan.
And HBM chips are those specialized stacked memory components that are absolutely crucial for getting the maximum performance out of AI accelerators like GPUs, right?
They are essential, and this investment is driven entirely by surging AI accelerator demand. It diversifies the supply chain away from traditional manufacturing hubs like Taiwan. The entire industry is actively mitigating geopolitical risk by distributing its manufacturing capacity globally.
And finally, there's a hardware innovation that seems to offer a potential long-term solution to this power crisis: the breakthrough in parallel optical matrix multiplication, or POM-MMM.
POM.
This sounds highly theoretical. Is this just lab science, or are companies actually deploying this now? How quickly could this alleviate the power crisis?
Well, it's moving very rapidly from the lab to commercial proof of concept. POMM is a key hardware innovation that fundamentally changes how computation is performed. Instead of using electrical signals, it uses a single coherent light pulse to perform many tensor operations simultaneously.
So light-speed computation for AI.
Basically, yes. And the benefit is orders of magnitude speedups combined with significantly lower energy consumption compared to traditional electronic computation.
So it's faster and more efficient.
Much more efficient. While widespread commercial deployment is still a few years out, the recent advancements indicate it is a viable long-term strategy for energy-efficient, light-speed AI computation. It offers the potential to ease that immense power bottleneck within the next 5 years. This is the ultimate hedge against the cooling crisis.
So we have these incredibly smart, verifiable software models. We have a deflationary economic shock making them affordable. And we have a high-stakes, government-backed race to build the physical infrastructure they require. Now, let's look at where these tools are being immediately deployed. In the most high-stakes, specialized domains like medicine and physical robotics.
The shift we are witnessing is AI moving from a theoretical model to a clinical partner. The new generation of verifiable AI, which can self-correct and reason, is fundamentally changing specialized domains like medicine, where the stakes for any error are the absolute highest.
And the dedicated research team has compiled a startling amount of applied science breakthroughs just from this past week, demonstrating AI's immediate utility.
Let's start with generative AI in drug discovery and genomics.
The pharmaceutical pipeline is notoriously slow and incredibly expensive. We saw 2 major generative models this week that seem to accelerate the shift from just screening existing molecules to actually designing entirely new ones.
This is the era of generative biology. First, we have a model called EVO. It's a genomic language model that has demonstrated the ability to generate entirely functional, novel proteins derived from bacterial DNA patterns.
And that's critical. It's not just a prediction in a computer, it's a functional protein that's been confirmed by actual lab tests.
Exactly. The application potential is huge, particularly for designing novel antimicrobials to combat the growing threat of drug-resistant bacteria, and for designing highly optimized enzymes for industrial or medical purposes.
And then there's Boltzgen, which is focusing on the most difficult targets.
Boltzgen is a generative AI that designs molecules for what the industry calls undruggable targets. These are therapeutic targets in the body that were previously considered inaccessible by traditional small molecule drugs. By rapidly accelerating these pipelines, Boltzgen is speeding up the discovery process for rare diseases.
And we're seeing big pharma responding to this, aren't we?
We are. Pfizer's massive strategic pivot toward AI-driven drug discovery, especially targeting the huge weight loss market, it signals that reliance on AI is moving from an optional experiment to a core survival strategy in the competitive life sciences domain.
And finally, in the diagnostic space, we saw POPI-V.
POPI, developed by Harvard and genomics researchers, is an AI model that scores genetic variants based on their likelihood of causing serious disease. It integrates sophisticated protein structure modeling to aid in rare disease diagnosis.
And how effective is it?
In a retrospective study, it successfully helped identify 2 new genes linked to rare diseases. This capability allows clinicians to flag harmful mutations quickly, which can dramatically accelerate diagnoses for patients who often face years of uncertainty.
The clinical utility of AI also extends to non-invasive diagnostics, especially in areas where early detection is absolutely paramount.
Yes, and the breakthroughs in dementia detection are highly compelling because this is a major global health challenge where traditional diagnostics are costly and often come far too late.
So what's the new development?
Researchers developed AI systems that analyze non-invasive EEG signals brainwave patterns, and they're capable of detecting Alzheimer's and frontotemporal dementia with up to 97% accuracy.
97%. That's a massive leap in accessibility for early diagnosis.
It is. But in the clinical world, accuracy is only half the battle. If an AI diagnoses a patient with Alzheimer's, the doctor needs to know why. That traditional black box problem prevents adoption.
Right, you can't just trust the machine without an explanation.
That is the crucial requirement for clinical adoption, and this specific model overcomes it. The AI includes an essential explainability layer. It highlights precisely which frequency bands in the EEG, the alpha, beta, gamma waves, and which spatial regions of the brain triggered the diagnosis.
So it's showing its work, just like the math model.
Exactly. This transparency is the prerequisite for trust. Clinicians must trust how the AI reached its diagnosis before they can trust the diagnosis itself. This verifiable reasoning connects directly back to our very first pillar.
We also saw significant advancements in imaging hardware itself.
Yes, Philips unveiled an AI-powered cardiac MRI suite that significantly improves both diagnostic speed and image sharpness. It's up to 3 times faster with 80% sharper images.
And why is that so important in a clinical setting?
This capability is vital because it makes it easier to scan patients who struggle to hold their breath, which is a common problem for the sick or the elderly. And that reduces the need for repeat scans and improves patient outcomes.
And one of the more unusual, almost science fiction-sounding breakthroughs was in sensory interfaces.
Ultrasound olfaction. Sounds incredible, right? Researchers demonstrated a technique using low-intensity focused ultrasound to stimulate the olfactory bulb.
Which enables
Non-invasive smell simulation.
non-invasive smell simulation. That's a highly specialized application. What's the immediate use case?
It opens immediate paths for sensory prosthetics, including medical therapies for common neurological conditions like post-COVID smell loss, or even advanced neurological research into how the brain processes scent without needing any physical stimulation. It's an early step toward AI models being able to interact directly with our biological senses.
So the final piece of applied science here is physical intelligence. If these agents are going to manage complex real-world tasks, they need robust methods for controlling robot bodies.
And the challenge, as our research team outlined, is what's known as the embodiment gap.
The embodiment gap.
We have millions of videos of humans performing tasks, but robots can't simply watch and learn because their physical capabilities, their kinematics, their movement dynamics are completely different from ours.
Can you define kinematics quickly for us?
Sure. Kinematics refers to the geometry of motion. It's essentially the rules governing how a robot's joints and limbs can move in space. And since different robots have different joint structures, learning from a human video is incredibly difficult.
And this is where a new method called TraceGen comes in.
It does. TraceGen is a novel method that ignores the visual appearance of the robot arm entirely. Instead, it predicts the 3D spatial trajectory, the trace of the desired action, so the path of the object the human is manipulating.
So it models the desired path of the action, not the specific robot doing the action.
Yeah.
And that path modeling can generalize across different robot bodies.
Exactly. By focusing on the path of the object and the gripper in 3D space, TraceGen allows a robot to learn a complex manipulation task with high success from as few as 5 uncalibrated human videos.
5 videos.
Just 5. It closes that embodiment gap efficiently, making training dramatically faster and cheaper.
And for more complex long-term planning, we saw the introduction of the BrainBody LLM Paradigm from NYU.
This is a hierarchical 2 LLM system. One LLM, the brain, plans the high-level tasks, something like prepare a meal. The second LLM, the body, refines the execution. It translates that high-level goal into specific granular robot actions like grasp the knife at XYZ coordinate.
And the real power here is the closed-loop feedback, isn't it?
Precisely. The robot tries the action. The body LLM reports back to the brain LLM if it failed, say the grip slipped, and the brain immediately plans a correction. This active planning and correction loop improved task success by approximately 17% over prior methods.
Pushing robots closer to the level of real-time adaptation they'll need for service robotics and complex home tasks.
That's the goal.
It's astonishing how all these different pieces, the reasoning, the memory, the infrastructure, and now the embodiment, are all converging at the same time. But now we have to turn to the inevitable societal and economic reckoning that these powerful new tools bring when they're deployed into the existing workforce.
The deployment of these advanced, verifiable agents is not a theoretical problem for the future workforce. The impacts are immediate, they are measurable, and they are highly concentrated in some pretty surprising areas.
And this is where the sheer competence and the cost-effectiveness of these new agents meet the reality of the job market, specifically the white-collar sector.
Yeah, okay.
The dedicated research team highlighted the findings of a really stark MIT study that was released this week. And this finding is incredibly unsettling because it focuses on economic feasibility, not just theoretical capability.
That's the critical difference. The study found that the AI systems we have right now can already perform tasks equivalent to 11.7% of the U.S. labor market today.
11.7%.
That figure represents approximately 15.1 million workers and $1.2 trillion in total wages.
So that 11.7% figure means that AI is already cheap enough, thanks to that deflationary shock we talked about, and it's competent enough, thanks to the verification breakthroughs, to replace those specific roles right now.
Right now. And the disruption is heavily concentrated in white-collar knowledge work roles that were previously considered insulated from automation.
Like what?
The study identified immediate vulnerability in administrative and cognitive tasks within fields like finance, healthcare administration, human resources, and legal services. These are the prime areas where an affordable, verifiable agent like Opus 4.5 would thrive.
The study's use of an iceberg index is a really powerful analogy. It suggests that while only a small fraction of this automation is visible right now, the massive potential impact on these white-collar roles is submerged just beneath the surface, and it's poised to emerge very rapidly as organizations pivot from pilot projects to full delegation.
It is.
What does this mean for a profession like, say, human resources?
Well, if you look at HR administration onboarding new employees, policy enforcement, benefits management, these are highly structured knowledge-based tasks. They rely on accessing massive amounts of organizational context, solving policy conflicts, and issuing verifiable communications.
A perfect job for an agent.
A perfect job. A system combining JAM for the memory and Opus 4.5 for the planning and verification could handle nearly all of this autonomously. The same applies to compliance work and legal drafting. This creates immediate, intense pressure on workers and on policymakers.
And governments are responding to this pace, but often with conflicting regulatory priorities that really reflect their own geopolitical strategies.
We saw two major signals this week. On the one hand, the EU signaled a more relaxed approach to the strict implementation of their EU AI Act.
Yeah.
They're simplifying regulations to avoid unnecessarily stifling innovation.
Which suggests European policymakers are focused on balancing safety with global competitiveness.
Right. Their focus remains on regulating high-risk applications of AI rather than trying to overburden the foundational models themselves.
And on the other hand, the U.S. response, that Genesis mission, is a strong policy signal that the U.S. views AI capacity as a national security imperative.
A totally different approach.
The focus is on prioritizing the rapid expansion of compute infrastructure and the acceleration of scientific discovery above all else.
The strategic contrast is significant. Europe is emphasizing societal integration and cautious, application-specific oversight. Meanwhile, the U.S. is emphasizing rapid expansion, geopolitical dominance, and scientific infrastructure as a strategic top-down approach.
If you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It truly helps us reach new listeners. For our listeners on YouTube, If you're finding this insightful, please take a moment to like this video, subscribe to Tomorrow Unveiled, and consider hitting that new hype button to help us reach more viewers. And of course, be sure to turn on notifications so you never miss an update on the future.
So if we synthesize all the breakthroughs we've discussed tonight, from the logic of DeepSeek to the agency of Opus 4.5, the memory systems, the local control, we can now, for the very first time, define the 4 confirmed and necessary capabilities of a fully autonomous digital worker.
And these are the 4 pillars of delegation that organizations are going to demand from here on out.
First, the ability to plan complex projects and reason about trade-offs, which we saw in Opus 4.5's active inference.
Second, the ability to execute tasks securely and locally, using visual perception, which was validated by Farrah 7b's architecture.
Third, the ability to audit its own work for logical errors and self-correct.
And that auditing capability, that speaks to something specific we're seeing rise, right? The idea of neurosymbolic AI.
It does. Neurosymbolic AI combines the probabilistic fluency of neural networks, that's the neuro part, with the verifiable step-by-step logic and rules of traditional programming, the symbolic part.
So it's the best of both worlds.
It is. This combination allows the model to reason logically and actually prove its steps, which is precisely what DeepSeek Math v2 demonstrated. This verifiable auditing is non-negotiable for real-world delegation.
And the fourth and final pillar.
The ability to remember context over months, maintaining state and persona, solved by systems like general agentic memory and those visual compression techniques. This is the complete blueprint for delegation, and every one of these components matured simultaneously this week.
So, to summarize the narrative of this crucial week on Tomorrow Unveiled, the AI world is no longer about chatbots. We are undergoing a fundamental, non-incremental shift from the stochastic guessing era to the delegation era.
That's it.
This transition is driven by verifiable intelligence, by aggressive cost compression that makes high intelligence affordable, and by foundational hardware investments that are now being treated as national security priorities.
The evidence collected by our research team is just overwhelming. The pilot phase of AI supervision is over. We are now entering the delegation phase where organizations have to confront the economic reality of that 11.7% displacement finding.
And the competitive advantage of the next decade.
It will belong to the organizations that can successfully assemble these disparate cognitive components, the verifiable brain, the long-term memory, the local execution, into cohesive, verifiable, and safe digital workforces.
The technical capacity gap has closed with incredible speed. The AI is now smart enough.
And that leads to the final provocative thought for you to take away. If AI can now reliably reason, self-correct, maintain long-term context, and achieve clinical utility with these new explainability layers, then the biggest remaining challenge isn't technical capacity.
What is it?
The biggest challenge is the human and institutional capacity to trust these systems enough to delegate safety-critical tasks. Think about autonomous code deployment into a live production environment, or providing those early explainable dementia diagnoses. The focus must now pivot and pivot decisively from building smarter AI to building safer, more accountable, and transparent human institutions that can govern and deploy these powerful new agents responsibly.
A profound thought to end on. Thank you for joining us for this deep dive into the unveiling of true AI agency here on Tomorrow Unveiled.
Until then.